G'day everyone, Paul Daniels here again. Alright, tonight I'm going to be building a small internal relay switch that I need so that I can actually use my my data recovery box. Up till now I've had one of the data recovery boxes with this internal relay and I've used it pretty much every day, but I do have a second one, but I really don't use it that much, and part of the reason is I don't have this internal relay that lets me switch on and off the hard drive. So I'm just going to quickly build one up here, and in another video I'll show you actually putting it into the data recovery box. Alright, well I'm going to be a little bit lazy here today. Rather than reflashing another controller, I'm just going to take it off this one here. Might take up some of the other parts as well, migrate them across. They're all pretty much identical, these things. I haven't actually, come to think of it, I may have to reflash this one. I just realized that's actually a programmer for other controllers, so nope, there goes that idea. Oh well, I'll just have to go get another microcontroller. Not a biggie, won't be a second. Alright, that's sorted out. So first thing I'm going to do is put that controller on. Got a few weird methods of doing this. Some people might sort of go, what the hell? But, years of soldering on these microcontrollers, I've sort of found quick and easy ways of doing it. Usually. Just wait for my soldering iron to get up to temperature. This is my 100-watt beast. Here comes the fun part. Okay, we're going to lose the audio pretty bad here. Flippin' cat hair. Don't get me wrong, I love my cats. But the cat hair does get in everything. Let's go for yellow-green for power. That sort of makes reasonable sense. Like I said, really, it's not going to be for much more than diagnostic purposes, because once this is in the computer case, no one's going to care. Yeah, I botched that up. Alright. Oh, that's right. We still have to do the flyback diode. Give me a flyback diode. Okay, now the purpose of the flyback diode is that when you have something like a relay, or any other coil for that matter, and it gets turned off, disconnected. Sorry, I'm just... Right. It gets pretty pissed off that the energy's got nowhere to go, and so as a consequence, the voltage across the terminals of the coil starts getting up pretty high until eventually it either causes a breakdown in the insulation somewhere, or it's got to go somewhere. So if you don't have the flyback catch diode, it will tend to just go straight back into your electronics and make things go pop. Interestingly, it's exactly the same principle or system that we depend on for so many things these days, such as switch mode controllers. So it's not a bad thing, you just got to know what it's doing so that you can apply the right things for it. Alright. Okay, now this is my MOSFET that controls the power going to the relay coil. These little SOT23 MOSFETs are amazing things. This particular one is about half an ohm resistance, which is nothing to write home about. But I have some other ones which drop down to around about 10 milliohms or slightly less than that, which is amazing considering that most of these about say 10-15 years ago, you get something like a 2N7002. That'd be about 10-20 ohms resistance, so they're pretty much no good for switching power. Now, it's amazing what you can do. You put 5 amps through one of those if you want at times. Wouldn't do it for a long time, but you can still do it. I now have to get my solder paste. Right. Where did I put that? I've just cleaned up my room, so everything's organised, which means I don't know where the hell anything is. Being organised is so disruptive. I should probably be keeping this paste, well, I know I should be keeping this paste in the fridge, but I would probably get killed for doing that because I've long since sold my fridge that I had specifically for electronics, which means there's only the household fridge, and you can bet your boots I'm not putting any sort of lead stuff in there, even if it is packaged up in a nice little baggie like this. You only need to stuff it up once, and then everything's going to be one crazy tea party. Alright. Now normally my hot air causes a lot of vibration in the pictures, so I'm hoping I've put some rubber matting under it, so I'm hoping it will reduce the vibration on the camera. Let's see how we go. I'm going to go for 460 degrees. It's not the highest this thing will go, but it's good enough, and about 72, 75, something like that. And I need to get my resonator. Okay. Yeah, that'll do. She'll be right, mate. Look at that, way too. Whoa, way off. Where do you think you're going? Oh, this one's slippery as. Okay, someone needs to turn the air down. Oops, wrong way. Okay, I'm down to 48% air now. That was way over the top. You've got to be kidding me. Okay, I'm just going to have to hold you. I ain't doing this right. What's going on? Something's very wrong there. Okay, let's try this again. Nope. The budgie way of doing the soldering. Tack and then hold. You have to do it 1 or 2 times, and the rest will come good. Till that happens. Come on, man. Keep it together. You can do it. I hold on to it for a little bit longer than normal because I want the solder to wick through to the other side as the current K-ring traces are on that other side. Oh, marvellous. Marvellous. Okay. Why do I get the feeling I'm missing something here? I don't think I am. Just a little paranoid. Nope, we're good. Alright. So. Well, it's looking like it's in pretty good shape. If you're wondering, this is for the programming interface. It's a 1.5mm pitch, just so that I don't accidentally put one of the connectors in by chance or anything. And this here is the USB interface. Because it's an internal unit, I actually do not use a USB. Oh, time's up. Yeah, this is a USB interface. Because it's an internal unit, I don't bother putting a USB plug in there or anything like that. Instead, it's just a 4-pin header, like so, and then that will I'll connect that up this 4-way flex, and I'll plug into the motherboard. Most motherboards have the USB pinheads. That's what we'll be relying on. Alright, here we go, more bodge job soldering. Amazingly, that came out dead straight, which almost never happens. Come on, bodge job, bodge job. Bodge job. Beautiful. So what do we got? Oh, naturally. Some idiot designer, whose name is not Paul Daniels, decided that it has to be interleaved like this. That's if I want to do fancy colours with, red being positive, black being ground, or I can just not care. Okay. Why is that? Come on. we go. Alright, now what's got to go here are the inputs for 12 volts and 5 volts for the drive, and here are the outputs. Now they're paired because one of them is normally open, the other one's normally closed, because it's with this relay. It's a dual switch. Here we go, got it written on here. So we've got the 12 volt side, and so we're normally open, normally closed, normally open, normally closed. For the purposes of this unit, we're going to go for the normally open, so that when it's not explicitly told to do anything, there's no power going through to the drive. I need to go get my serial ATA cable. Alright, back later. Alright, this is my serial ATA cable. It's just one that I buy from my electronics supplier. So he's got the female end, or male end too. And then what we're going to do is we're going to cut 2 of these lines. Oh, crikey, now I can't even remember which 2 I'm supposed to cut. Alright, quick, someone shout out and tell me from the future which 2 it's supposed to be. I'm pretty sure it's the red and yellow. Yeah, the orange is some other voltage. I better go check. Yep, I was right. Red is 5, yellow is 12. I knew that. And what? Put them on the outside pair, and then also on here. Okay, I'm just going to put it back into this contraption. Not a great fan of these board holders, but they do the job. Okay, so 12 volts in this case is going to be there. Great. So we're going to put middle. Right, from here I just need to give it a wash, flash the controller, and make sure it all works, and then we'll connect it up to the machine inside, and I will do another video for that. Okay, well, we'll consider this a working board for now, and if it's not, I'm going to have to keep fixing it until it is, but we'll assume that if you see the next video, then it did work. Alright, thanks for watching, and I'll see you next time.